So we are going through problems from WebWorks section 3-4. Problem 1. My problem has two parts. Now the second part will appear after you answer the first part correctly. Okay. I have already done this problem once. That's why I am able to see both the parts. You probably will see only part 1. After you input your answers here, you will be able to see the other two parts. Okay. Now, what are the vertical asymptotes of this function? Your answer should be a number, a list of numbers separated by commas, or none. All right. So either you'll get one number or several numbers. You have to enter them by using commas. Or if you have no answer, you should be writing none. That's what they want. Vertical asymptotes. So this is my question. Okay. Fx equals 3x squared over x squared minus 36. Now you want to look for vertical asymptotes of this function. Notice, for this we need to factorize the denominators and numerators. Why? Sometimes you factor the denominator and numerator and factors cancel. When those factors cancel, they do not contribute to the vertical asymptotes. Okay, so they do not contribute to the zeros also upstairs. So one has to be mindful. Make sure when you factorize that things don't cancel. If they cancel, you need a different theory, slightly different theory. Okay, now so we look for factors of the denominators which do not get cancelled by the factors of the numerator. Numerator is 3x squared. Well, what are the factors of 3x squared? 3x, x repeats. All right. What about the denominator? That is x squared minus 36. This is difference of squares, you see. So that is x minus 6, x plus 6. Now, look at the numerator and denominator factors. 3xx, x minus 6, x plus 6. There are no common factors, no cancellations. So we are fine to proceed. Zeros of the denominator after cancellations of factors, if any. So this is an important thing to note. If you had any common factors upstairs and downstairs, you would cancel them and then see what remains. Say suppose you had an x below, right? No, let's say you had an x plus 6 below and an x plus 6 above. You would cancel those x plus 6's and then see what's left over. The zeros of whatever is left over, they give you vertical asymptotes. So in our case, you have x squared minus 36 is 0, x minus 6, x plus 6 is 0. Therefore, the first factor gives you 6, second factor gives you negative 6. I will enter with the smaller number first, x equals negative 6 or 6. So the vertical asymptotes are negative 6 and 6. Okay, so I will write the negative smaller number first, then the larger number. Don't forget to separate them by comma. All right, once you did that, what's the next question? Next question is find the following left and right hand limits at negative 6, left and right hand limits at positive 6. So whatever you enter here, if what you enter is correct, then the second question will show up with those numbers. So they want you to say either negative infinity, enter I for infinity, negative I for negative infinity, or D and E for does not exist. All right. So you're looking at left hand limit and right hand limit. Now this requires a little more thinking. Okay. So let's worry about zeros of the numerator also. For this, you need to do that. You need to look at the numerator, because why do I need to worry about this? This is where you get x-intercepts. As long as the factors do not cancel. Aha! Again the same problem. If some of the factors were to cancel from the top, whatever is left behind, you look at its zeros. Whatever cancels, they do not contribute to x-intercept. Whatever survives after cancellations contribute to x-intercepts. Just as in the denominator, whatever survives after cancellations contribute to vertical asymptotes. All right. Zeros of the denominators after cancellations contribute to vertical asymptotes. Zeros of the numerator after cancellations contribute to the x-intercepts. So, notice in our case we have no problem. There are no cancellations between numerator and denominator. So, all you're looking for it is zeros of the numerator. 3x squared. So, let me remind you, numerator is 3x squared. 3x squared is 0, x squared is 0, so x is 0. Alright. So, there is nothing else. X is 0. So, here I have the following picture. Number line 0, 6 and negative 6 we have determined to be vertical asymptotes. That's why I have these dotted lines. At 0 I have an x-intercept. So that point is a solid point. My curve will go through that point. Now question is, what happens in the remaining region? What are remaining region? 1, 2, 3, 4 intervals. They are negative infinity to negative 6, negative 6 to 0, 0 to 6, and 6 to infinity. Okay, I want to know whether my curve is above or below. Okay, choose any number from this left hand side, this particular huge interval. Any number. I chose negative 7. All right, that is my test point. I'll plug in negative 7 in this expression. I've just written down negative 7 in parentheses for x. Okay? I don't care about the actual value. I just want to see the sign. What happens to the numerator? Negative 7 is going to be squared. That gives me a positive. Positive times positive is a positive. So that's good. Numerator gives me positive. Denominator, negative 7 quantity squared gives me 49, positive 49 minus 36. So this is also a positive. So I'm going to get a positive over a positive. Positive over a positive is a positive. Aha, so that's good. What does that tell me? That tells me I am positive here. In other words, my curve will go above. All right, whatever it does, it will not cross x-axis. Why not? Because it crosses x-axis only here at this point. That's the meaning of an x-intercept. We saw the only x-intercept is when x is 0. The numerator is 0. All right. Likewise, now let's choose a test point from here. You can choose any number between 0 and negative 6, right? Any number. I chose negative 1. You could have chosen negative 2, negative 5, whatever you like, as long as it's within this interval. You cannot choose the end points, mind you. Something within the interval. I plugged in negative 1. So, what is the sign? Upstairs is plus. What happens downstairs? Okay, I hope it's clear. Upstairs is plus because I'm squaring a negative number inside parentheses. So that's a plus. Downstairs, negative 1 squared is positive 1 minus 36. Aha, 36 is too big. Overall, it's negative downstairs. Positive over negative is a negative. So, what happens here? I have a negative. In other words, okay. In other words, my curve is going to be below here. Understand? Next, here, I'm on the third interval, 0 to 6. You can choose any number you like. I chose 1. You could have chosen 2, 3, 4, whatever you like. I chose 1. So what happens here? Upstairs is positive. Downstairs, Same story is negative. So this gives me overall a negative. All right. Going back, this is a negative. All right. Now, lastly, for this interval, 6 onwards, choose any number you like. I chose 7. Plug it in your function f. You get 3 7 squared. So the same story as before. Upstairs is positive. Denominator is 49 minus 36. I don't care about the value, but I care about the sign. It's a positive. All right. So the point of this is the following. I know my curve is here. All right. Goes through this point. But here they are negative. In other words, my curve is something like this. It's below the x-axis, both sides. But I know this is my vertical asymptote. So this curve has to go to negative infinity here. Likewise, this is a vertical asymptote. So this curve goes to negative infinity here. What about here? I know my curve is above. This is a vertical asymptote. So it goes like that. Likewise, here it's above. It has to go above. Okay. Large terms. So I don't know what's happening when x approaches infinity. X approaches negative infinity. That's not part of my question. Notice, I'm not looking at limits at infinity right now. Okay. So this brings me to my answer. Let's see the picture. It's easier to see, answer this using the picture. Question is, limit x approaching negative 6 from the left to the left of negative 6. When I come near negative 6, my curve goes to the top. That is a positive infinity. To write positive infinity, I need to write I. Likewise, if I'm going to negative 6 from the right hand side, when I'm to the right of negative 6, I go down. You see, approaching negative 6 from the right, my curve starts going down. So it's a negative I. Likewise, let's go to 6 from the left hand side. 6 is here. X is approaching 6 from the left. My curve falls down. So this is a negative I. When I'm approaching 6 from the right hand side, so x approaches 6 from the right hand side, my curve goes to the top. Why does it go to the top? Because I have a positive sign. So that gives me an I. Okay, let me submit and hope and pray everything is good. Okay, until next problem then, guys.